In MCQ 26, we are tasked to find out the different acidity for these various compounds and to determine which of them are actually the most acidic. So when it comes to organic chemistry, the acidity of a compound is very much dependent on the stability of conjugate base. And conjugate base itself are actually negatively charged carb and ion. So depending on the groups that are found on the carb and ion itself, the greater the dispersal of the negative charge of the carb and ion, this will actually increase the acid dissociation constant Ka, and since Ka is inversely proportional to pKa, a much higher Ka is the same of having a much lower pKa. So the question asks, why is the 2-hydroxybenzoic acid much more acidic as compared to the 4-hydroxybenzoic? So you can see that we are dealing with a 2.98 pKa for the 2-hydroxybenzoic, but a 4.58 for the 4-hydroxybenzoic acid. So let's first start off by drawing its conjugate base. For the 2-hydroxy, the hydroxyl group will not be dissociating because it's a much weaker acid as compared to carboxylic acid. So carboxylic will be the first to go to dissociate. So this is actually the first conjugate base for the 2-hydroxybenzoic acid. Now for the case for the 4-hydroxy, similarly the hydroxyl group will not be dissociating, but the carboxyl group will be dissociating. Now naturally within each of them, there is the delocalization of negative charge within the carboxylate ion, as negative charge is delocalized over 1 carbon and 2 oxygen atoms. So it is dispersed by itself. But if you take a look at the polarization between OH, we have an electropositive hydrogen, as well as 2 lone pairs that is found on oxygen itself. But you do also have that lone pair found on the O- ions itself, and because of the close vicinity in your 2-hydroxybenzoic acid, the negative charge on the O- itself is able to form an intramolecular hydrogen bond with the adjacent hydroxyl group that has yet to dissociate, further dispersing the negative charge. But for the case for the 4-hydroxybenzoic acid, because both of the functional groups are a distance apart, they are unable to form intra-H bond. And this means that it does not have the additional stability as compared to the positional isomer of 2-hydroxybenzoic acid. So for this question over here, the answer we're looking at is going to be B. This internal hydrogen bond is formed between your conjugate base, COO- and the nearby substituent of OH for an intramolecular hydrogen bond.